All right. All right, guys. So, in case for those of you watching on YouTube, the question for today was, what is your favorite movie? I said The Dark Knight because it's just the best Batman movie. Um, and our lesson for today is going to be transformation and congruence. And our objective for this lesson is to be able to use geometric descriptions. So, in other words, rigid transformations to be able to define congruence. So, in other words, another way of kind of defining this is two things are congruent if you can do rigid transformations or rigid motions. So, remember, rigid motions were, let me list them. That way you guys have visuals. Rigid motions, there's my pen. So, rigid motions for review was translations. Translations are rigid motion. It's not changing anything, you're just translating it. Reflection. The size and shape stay the same, even though it kind of moves over. And rotation. And rotation is like if you're doing a screwdriver and stuff like that. We went over, this was listed in the activity. You were supposed to give examples of this. Dilation was one of them, but dilation is not a rigid motion. It does change size and shape, or not shape so much. It changes size, so it's not considered a rigid motion. It is a transformation, but not a rigid motion. All right, so we're gonna get into this on talking about how if things are congruent. Like so, for example, this reflection right here shows that all of these are congruent. These are not congruent because they're different shapes or different sizes. They're the same shape, just different sizes. So we'll learn about this later. They're called similar. The orange are all congruent, but these black ones are similar. All these black ones are congruent, and this one looks a little bigger, so I would say this is similar. It's just bigger, different size, same shape, different size. So we're gonna get into this. So again, we're gonna use GeoGebra. GeoGebra is how we're going to prove most of our things. So here, if we look at this, this is our original shape. Let me zoom out a little bit. Let's see. Oh, nope, that's search. I hate how the magnifying glass is search. I want zoom out. How do I zoom out? Control minus? No, that does the whole thing. Oh, I'm just going to use my mouse. I'm not sure how you guys do it without the mouse. I use the scroller on my mouse to kind of do this. So what we're going to look here is this is our original pattern, and we're going to see if somehow we can map these onto each other. So take a look. So first work on stencil one. We're going to start on this stencil one, and we're going to use reflection. So we're going to try to move this over here. So you guys might have a different way of doing it than I do, but I'm going to try all kinds of stuff. I'm going to try rotating this, see if rotating it helps. So in order to rotate, you have to have a point. So I'm going to put a little point right there to see if I can rotate this. And I'm going to do this. This right here is going to be all of our transformations. So I'm going to try to rotate around the point. So I'm going to click my shape, click my point, and I want to do like 90 degrees, and I want to go this way, which is clockwise. So I'm going to go here. I'm going to go to 90. I'm going to do clockwise. Boom. So it looks like it's not exactly working out the way I wanted it. It looks like it's a little different. So what I'm going to do from here is I am also going to reflect it because it looks like it's backwards. So I'm going to click on here. And again, you guys might have a completely different way of doing this. Um, I can already think of another way of doing this. So I'm gonna reflect. Did this reflect? It doesn't look like it's reflecting. No. Reflect about line here. Axis. Cool. So it looks a little bit better. And then I am going to translate this. This one is really hard to do for some reason. You click translate by vector, click this, hold it down, and then move it over. So that looks like it worked for me. So here, I don't care so much about how you're describing it. Maybe some of it a little bit, but but when you're describing it, you could do something like, so first thing I did was rotation 90 degrees clockwise, so CW. From there, I did reflection about X axis. And then I translated up and to the right. So I only had to use 3 transformations. I could have used 4, like I could have done a translation up and then a translation to the right. But I only used 3 transformations. So let me undo these. And there's a bunch of other ways you can do this too. Like one way that I thought of later was if I made a line. So let's say I made a line, the x negative 1. If I reflected this over the x negative 1 line, see how it's a little more set up, and then I could translate it. I would literally be able to do it in 2 transformations. So all of you guys might have different ways of translating that one. That's just the way I did it. All right. So the next one I see here for stencil 2, well, let's see what it did here. Does the stencil overlap? Exactly. So does it overlap exactly after transformation complete? What can you say about the points in the stencil? Use this. Um, so I would say yes, it overlaps exactly. The stencil is the same as the original. And we're not going to use the word the same. We're going to say the stencil is congruent to the original. To explain it, I would say because it is, or it has the same size and shape. That's all you really need to say there. It's like, well, what can you say about? Well, they're congruent. Why? Because they have the same size and shape. They want you to kind of describe it as you could do a series of rigid transformations to do it. In fact, I think that's exactly what they say. The pattern, blah blah blah. Each stencil. Oh, no, they actually say it pretty much the same way I do, just with different words. Make sure you're using your own words for your answers, though. So now we're going to consider this next one. So stencil 2. This one, I honestly think stencil 2 is a lot easier because I can already see that it's a little backwards. So I'm going to use reflection about line. I'm going to reflect it over the y-axis. If this lets me. There we go. And then I'm just going to use translation, which again, this one's probably the hardest, and unfortunately, it's the one that we need to do the most. So I'm going to click it and drag it and try to overlap it as best I can. And it looks like it's a little off. It looks like this one doesn't have the exact size and shape. I'm not sure if I'm seeing it wrong, but I would say stencil 2 doesn't have the exact same size and shape. If you look, it doesn't look, even if I were to zoom in, you can see that there's a little bit of a gap there. So this one doesn't have the same size and shape. So what I did was, first thing I did was reflect about the y axis, translate up and to the right. So I don't necessarily want you guys to put the exact numbers. I don't know if they want you to put the exact numbers. Yeah, they put the exact numbers. I think that's a little too much. As long as you're telling me it's up and to the right, it's really hard to figure out how much you moved it by. I think even if you have the algebra mode on, it doesn't even tell you. Oh, actually, it does. The way it tells you kind of here is, oh, it doesn't really tell you. Yeah, and I don't necessarily want to go into this. This tells us a vector. Vectors is something you're not even going to do until pre-calculus, so I don't want to get into the vectors. I'm going to hide this for now because it's not going to help us. Close this view. There we go. All right, and then does it does not overlap exactly. One of one of vertices does not touch after the transformation. This means the shapes are not congruent. And that's all you really have to say. Should the printer use stencil 1 or stencil 2 for the project? Explain why. They should use stencil 1. 1, explain why. It will produce, or you can say make, whatever you want. It will produce the same size and shape. And I think I've mentioned this before, but try to just take notes. I know it takes more time to take notes and then do this on your own, but I think that's the best way to kind of do this. Because you can always rewatch the YouTube videos later and work on it at the same time. Right now is a good time to kind of just ask questions. Does everyone understand all of this? Everybody good on this? Are you guys awake? Can you guys hear me okay? Okay, cool. Just making sure you guys are still there. All right, cool. All right. So now we're gonna hope that this loads. Go to 6. So stencil 1. Oh, it looks like there's more than that. They're showing how different the pattern is. All right, so now we're going to talk about other shapes. So other shapes we can rotate. We can see if these go. They're talking about how we can rotate it. So they're getting specific with it. I'm not too strict on this. Later on, we will end up talking about it a little bit more. But for right now, as long as you're telling me it's going up and down, that's fine. The angles and rotation, I do kind of want you to be a little specific on those because you physically type those in. So a figure maps onto another using one or more translations, reflections, or rotation. what must be true? The figures must be congruent. So that's this idea that as long as you're using rigid transformation, the figures are congruent. Quadrilateral uses these vertices. The vertices of the next quadrilateral is this. Which single transformation would do this? So if we look here, see how the y values are negative, but the x values are exactly the same? This was a rule we had. So I'm not sure if you remember your rules. This you should honestly write down your rules. So your reflection rules, because I've been grading the Unit 1 activities, and some people got the reflection rules wrong. The reflection rules is if we start with x, y, and we're reflecting it 180 degrees, or if we're reflecting it over the y-axis, so we're going to reflect over the y-axis. What this does is this produces it to be the x value would turn negative and the y value, so the x value changes. So that's your rule for the y-axis. The rule for the x-axis is essentially a little bit different. It means that the y value changes signs. And that's what's happening here. All of the y values are changing signs. It just so happens that it's going from positive to negative, but it can easily just have gone from negative to positive. And remember, you guys also have rotation rules, so make sure you guys look those up. You can actually look those rules up on Google. So let me open this up. Rotation transformation rules. And we usually use counterclockwise. So these rules are here. It shows you what's happening. You're going from this, so if you rotate 90 degrees. So you can always look these rules up, but I recommend having them written down. That way, when you're doing things like this, it makes a little more sense. So make sure you have those rules written down somewhere or know where you can find them. So we said we're going to reflect over the x-axis. Which pair of polygons is congruent? So in other words, which ones are the same shape? So first instinct would be to get the ones that kind of look like squares. But if we look here, it's a little bit off. This side is a little longer. So we know these two are congruent, and this one won't match up with any of the other ones. This one won't either. This one is 2 by 1, 2, 3, 4, 2 by 4. This one is 2 by 1, 2, 3. And this one over here is 2 by 3 also. So the answer would be polygon 3 and polygon 5. So 3 and 5. All right. And our next one. Oh, and then we're just talking about summary. So congruence seems like an obvious idea, but it's just recognizing if things are congruent is really hard to do in real life. You have to make sure they're the exact same size and shape so they can be done off rigid transformation. So I know some of you guys are still working on the other thing. So since we still have a lot of time in class, I kind of wanted to go over the tutorial or the unit activity. So that's going to be a treat for you guys in class because I'm actually going to stop the record. Well, no, I'll leave the recording on. I usually like leaving help for the activities um, for you guys who attended class, but I'll leave this on. And you guys can ask me questions if you guys are struggling with it. So give me a second while I go onto my student account one. So log in Admentum. Let me see if I can find it because I hardly ever go on my student account one. We're doing geometry, all activities. So, transformations. So, when you're doing this, also, if I ever return it, guys, I'll always put little comments on what you could have done better here. It basically, what I do is I take this rubric, copy and paste it, and underneath these, I will write little comments on what you could have done better or what was wrong with it. And if you do it like you get your full credit, I'll just mark down that's 1 out of 1. If you got some points taken off, it'll be like, I don't know, 0.5 out of 1. You can always look at that for feedback. If you want to resubmit it, you guys can. You just have to let me know. So when we're talking about translations, you're moving how many units up? So all of your answers, and I've seen people mark this down wrong a lot. Um, Give me a second. Well, oh, I don't have my tool. All of these should be in the form like x comma y, and then it kind of goes into, I'm just going to use a less than or greater than sign to make an arrow. And if you're going up a certain amount of units to the right, or I'm sorry, if you're going a units to the right, you would go like a and then show something, or x show something there, and then a comma y something b. I'm not going to tell you guys what the something is, especially since this is being recorded, but that's how you do this. And then with the reflection, I already went over the reflection rules. So you start off at x comma y, and you're going to go like this. So I figured this was a good time to go over this, not only because we have enough time, but also because I saw a lot of like errors on this. And you're going to write this as whatever your new x value is, comma, whatever your new y value is. And we went over those, and we went over the rotation rules. This is why I Googled the counterclockwise, because it's asking you for it counterclockwise. Also, how do functions differ from algebra? So remember, these functions, look at this, it's two different things, right? It's an x and a y. Usually when we're talking about algebra, it would be something like y equals mx plus b. All the changes are only, oops, it's supposed to be plus b. All the changes are only happening to the x. You're not making any changes to the y when you're doing functions in algebra. So that might be something you want to write about. This one, you're combining all the rules together. Is this making sense so far, guys? Do any of you have questions about the unit activity so far? Let me know, guys. This is time to ask. Did you say something, Alonso? I can't hear you for some reason. I'm not sure if that's my. Give me a second. My headset's not working. Could you repeat yourself, Alonso? I didn't hear you the first time. Oh, you're learning about this? All right, cool. Um, so this thing right here, when we're doing the rotation, we want to follow the rule, whatever rule we do for the rotation here. But then we also have to do the rule for reflecting across the x-axis. So there's two things happening here. So first you do this rule, and then you have to do this rule. So that's how come here they're showing what happens to the point first, and then it happens later. But these have like numbers. Here you won't have numbers. You'll just have like A and B. So you won't know what your A and B are. So you're just going to put like minus B or minus A plus. So that's why they're kind of giving you the example here that you're doing stuff. So this is how you can read this. So this will help you out. The next thing, give me a second. So if you go to the next slide, we're going to have to follow all of these rules. So I saw a lot of people followed the first rule. The first rule is pretty easy. You just have to use all the shapes. The second rule, each field has to be adjacent to at least one building. That's where a lot of people are losing points. Adjacent means that everything has to be next to a building somehow. I've seen some people do it like this too. It's technically adjacent. So as long as it's touching it. Some people I've seen have these like this, and they won't have like a building. And I'm like, whoa, you need to have like a building touching this. Another one, it's like two or more fields can be adjacent, but they can't share the same side or boundary. That just means like, for example, if you have these, you don't want them to be like exactly the same. So if this is your right boundary, you can't have them touching each other or overlapping basically. So this is okay. These are, we'll get into why this is not okay in a second. But just as long as it's not touching the same side. So for example, the soccer fields are more obvious. You want something in between these soccer fields. You don't want them sharing the same side. Baseball fields, it's really kind of hard to make it touch the same size, but time to get into the baseball field ones. They don't want any of this curved side going into the other one. So obviously this is a big no-no. Your ball's going to go into this field. This ball's going to go into that field. Even if you have it like this ball can still go into that field. But if you have it like this, it's okay. It doesn't touch each other. So that's this. So make sure all of them touch a building. I've seen some people get creative. They'll put like a building in the middle, so that way it touches the most amount of buildings or fields. One building touches more fields. And for this last one, you're just doing examples. So what's an example of translation? Pushing something, reflection, looking through a mirror, looking at water. What's another example? Things like that. Dilation. I've seen some examples of like a balloon, of making a picture bigger or smaller on the computer. Rotations. One of the biggest ones I've seen is like the clock. What's another one? Like turning a screwdriver. That one I thought was pretty creative. But that's what we're doing here. Anybody else have any questions on how to do the activity? I know that the activities are usually very different. That's why whenever I have time, I try to cover. You got them?
In this activity, you will apply your learning about transformations to solve problems. You'll represent.
I forget that I have autoplay on. I don't know what this is. All right. Other than that, guys, just make sure to answer the questions. I only have 2 of you answering the questions so far. I've never seen the platform. I'll check it out, Jasmine. Let me turn this off.